So this is the video which I would like to share with the LeapBridge users. So there are two options. One is the BIM workflow and standalone workflow. In this, I'll be selecting the standalone workflow. User needs to click on LeapBridge Concrete module. Then if the user clicks, user can create a bridge model and save it as a ABC dataset. A master dataset can be created and saved in the particular path, and it can be reused again with the changed geometric values. So to see where it is stored, user needs to go to option and select ABC dataset option. Here user can save as the master dataset and also can activate that particular dataset. I've just activated the data set, and here you can see all the information is populated, the alignment information, vertical profile, cross section, the spacing, the number of spans, the spacing between the girders, and if any advanced definition needs to be provided for a flayed girder, there is an option called advanced definition. So next, the substructure data, user can model the hammerhead pier. We have predefined templates over there with the isolated footing, pile footing, with the beam seats. In the second pier, we'll be modeling a straddle bent pier. The third pier will be a straddle bent pier as well, and the last pier will be a hammerhead pier with isolated pile cap. So the user can select number of piles. We already have some predefined library templates. Abutment, we have two options. One is stem wall abutment, and the other one is pile cap abutment, wherein the piles are designed as the columns which are integrated with the pile cap. So finally, click the next option. Here, user can input all the material data, the bearing data, and he can check the summary if all the information is fine. If there is some issue, the user needs to go back and fix that issue, and finally click on finish button. Then in the geometry tab, the user should be able to see the 3D view of the bridge. User can click on the tree and then see the alignment, profile, and cross-section information there. If the user wants to move the straddle bent, then the user has to. If the user wants to move the straddle bent by a particular distance or an offset, he has to first check the flayed girder option, click on the layout, click on the pier, input alignment offset as 20 feet. The same thing needs to be done for the pier 2 as well. So with this, the program will move the straddle bent, as you can see in the bottom window, will move the straddle bent by 20 feet. And the same thing can be seen in the 3D view as well. So all the load information is inputted there, and finally the analysis is performed. And finally, the beam design is done in the strand pattern dialog box. So we need to update the file to save the file. Once it is updated and saved, the ABC option gets deactivated. The user will not be able to make any further changes to the geometry. So we need to save the file, give a name to it. Then we can go to the substructure, wherein we can select the piers from the drop-down menu. It can be abutment, piers. As you can see here, the abutment has been selected here and updated just to check all the information is fine. The pier 1. As you can see, the beam seat. Beam seat elevation, the transparency mode, user can see the frame, how it looks like, how the analysis is performed, the node numbers, the member numbers. So all those information can be checked here. Then the pier 2, which is a straddle bent pier. User can go to individual modules, and they can add the loads and perform the design of the cap, column, and the footing. Finally, this is the second straddle bed. And here you can see the negative 20 feet offset, which was inputted in the superstructure. It can be seen here, just to check if everything is fine. Then finally, the final hammer at pier. The process is pretty much same. I have made the workflow very easy for the engineers to follow. So we have an option called in the project geometry tab, under construction tab. We have an option wherein user can see the animation of the construction phases of different bridge elements. And the same thing gets highlighted on the top window in red as well. So it's a quite useful tool for engineers when they want to when get into the construction. So now save the file, update it, and save the file. So it is saved under the OBD. So in the next slide, I would like to go through the same process using screenshots. How to define bridges. Bridge geometry can be done by using ABC wizard. User can save the ABC dataset and use it for subsequent geometry changes. Okay, and here you can see the bridge element tree, where user can select the options here, the different bridge elements, and the same information can be seen in red, and those substructure elements can be seen in the bottom window. So in the next slide, here you can see, as I mentioned, the construction phases, wherein user can see the animation of the construction phases, which can be seen in red, as well as same information can be seen at the bottom, how the program is placing the girders above the substructure. So what are the steps to create a bridge using ABC wizard? User needs to define the alignment, profile, and cross section. User has to define span length, skew angle of the support. User has to define the girders and the superstructure. Use advanced definition for flared girders. It's over here, the advanced definition. And in the substructure, if the user clicks next in the substructure window, user can we already have predefined templates for straddle bent pier, multiple column pier, hammerhead pier, wall pier, and pile bent. User can select the hammerhead pier option from the drop down menu, and in the bottom window, user can customize the steps, the bridge steps, and the pile group. User can model the isolated pile footing, so that information can be inputted here. Similarly, for the abutment, there are two options, as I mentioned before. One is stem wall abutment, and the other one is the pier cap abutment. For the stem wall, the user can provide pile footing over there, or isolated footing. For pile cap, the user can input the number of piles below the pile cap, and the program will analyze the pile cap as a continuous beam or integrated column pier, which analyzes the whole system as a frame. So in the next slide, so when all the superstructure substructure information is added, and if the user clicks next option, finally, as you can see here, the straddle bent pier has been modeled here. The modeling is quite easy, as the user has to just input the geometric information here. So once all the information is added here, the user needs to check if the summary information is fine. If the summary information is not good, the user has to click back button and go and modify the information and rectify it, and again click the finish button. So in the same window, the summary window, user can input the material data, the bearing data, and other information over here. This is quite critical. As I mentioned before, the user can create a master ABC data set over here. So user can model the ABC data set and save it here, give a save as here, or add or update button. Then if they want to modify the geometry and check some other configuration, they have to click on Save As. And if they want to activate any particular ABC dataset which they want to analyze and design, the user has to click on Activate Set. And the program will populate all the geometric information in the ABC wizard. So where this information is stored, user has to go to Preferences, ABC dataset path. If the user clicks on the 3-dot button over here, the program will automatically take you to that particular path where all the ABC dataset information is stored. So in the next slide, moving the straddle bent, as I've shown in the video, the user has to check the flayed girder option, and in the Superstructure tab, user has to click on the Layout option. In the bridge component layout, user has to click on the pier under reference name and input the alignment offset information here, which is 20 feet in this case for both the straddle bent. And as you can see here, the straddle bent is located at the center, and the same thing has been moved by 20 feet in the another window. So how to navigate substructure module? As you can see here, user has to click on the substructure tab, and then the user needs to select the particular pier or abutment from the drop-down menu. The type of pier the user selects, it's highlighted in red, and the same information can be seen in 2D. So here, user can double-click or get a print of it and check if all the dimensions are in good shape. If everything is fine, the user can update and save the file. If not, the user should not update and save the file at this point. Otherwise, the program will deactivate the ABC wizard. So if some information is not fine, just don't save it or update it. You can go back, modify that information, and then finally update the file.
Thanks for watching. If you found this video helpful, please give it a like and share it with others. If you want to see more like it, please consider subscribing to this and Bentley's other channels. Thank you, and see you next time.